All right, so let me go ahead and start kind of the official part of tonight's class. And obviously the topic is probability. Let me actually go ahead and make sure the chat area, where's the chat? Okay, so I'll still be able to see you guys on chat. That's what I want. Okay, so I'll be able to see the chat while we're talking through this, and you guys can go ahead and still kind of post comments and questions as we're going through, and I'll try to follow those as we're going. If you guys have questions, I'm going to give you a heads up that I'm going to go really, really fast. We have a ton of content to cover. Just to kind of give you kind of some perspective on what we're talking about. I'm going to try to teach you everything that I teach in the probability lessons in my full GRE prep course. And so it's a lot of material. I mean, it's several hours of content, and I'm going to try to squeeze it down into about an hour. And so if you feel like I'm going too fast, if you don't feel like you're fully getting what I'm saying, that's okay. It's kind of normal because I'm going to go through everything quickly. You're going to need to kind of digest this information over time. And I'll try to send the recording, assuming the recording works. I'll send you a link either later tonight or tomorrow so you can go back and rewatch it and pause and rewind and do whatever you need to make sure that you learn the material. But we are going to talk about probability. It's kind of one half of a coin, right? I teach the lessons in my course as probability and combinatorics. Combinatorics meaning counting, combinations, and permutations. And that really kind of builds on what we're going to learn here in probability. I'm going to stick with probability here, but before we dive in, I just kind of want to introduce myself and kind of give you guys a little bit of background and perspective on what we're talking about. And why are you here? And actually, I'll ask you to type in the chat area. I'm curious, what sort of grad program are you guys trying to apply for? Law school, maybe a master's in education or nursing. Maybe you're looking to go to business school. Maybe you're looking to get an MBA. Perfect. I see an MPH, right? I love this cartoon. My aspirations to be a Buddhist monk were dashed when I failed the monastic aptitude test. You know, it does seem like this GRE is kind of the gatekeeper to that next chapter in your life, in your education, right? MBA in entertainment, awesome, management. Yeah, fingers crossed, we'll help you get there. So it is that stepping stone, but the good news is it's a beatable test. And I was actually exactly where you guys are now. This is me actually sitting at my first job in Washington, D.C. I was working for a startup PR firm after I graduated my undergrad from Duke. Ended up going into the Peace Corps first, came back, and here I was kind of grinding away at my first job, and it was awesome. There's a lot of exciting stuff going on working on Capitol Hill. And I came to a point, just kind of a realization where if I wanted to get where I wanted to go in my life, I needed to go back to school. And to get there, I had to take the GRE, right? And so that's exactly where you guys are. And it's unfortunately a process you simply have to go through. The good news is it's a beatable test. You've probably heard me say that if you've watched any of my other videos. And that's something that I came to realize not only as I was studying for the GRE, here's me actually in a classroom. So what happened was I went to grad school, did really well on the GRE, and then I applied to actually teach the GRE and the GMAT for kind of a leading test prep company based out of Denver, Colorado, where I was in graduate school. And I'll never forget my interview process for that job. And this story has relevance because I wanted to help frame your thinking, right? We're going to talk about probability specifically in this class today, but I want to frame your thinking about really how to think about studying for the GRE, how to approach the GRE, how to tackle the GRE. And what happened for me was I sat down and kind of went through some initial questions with the guy who was going to be hiring me. And then he gave me a quiz. Again, I don't know, 10 questions, 20 questions, whatever it was. And he left the room and he said, you know, take as long as you need, but answer these questions. And so I started answering the questions. They were a bunch of former GRE questions. And I got to a question that was hard, and I didn't immediately know how to solve it. And I started to kind of panic because in my mind, I figured I probably need to get every one of these questions right if I'm going to be qualified to teach the course, right? I'm supposed to know this stuff if I'm going to be the teacher. What do I do? Because I don't immediately know how to do it. And what happened was I kind of took a mental step back. I thought about my own preparation, my own situation on the GRE. And I came at the question from a non-traditional, kind of non-standard way. I got creative. Rather than trying to solve the question in the traditional way, I kind of sidestepped and figured it out and kind of reasoned my way to a right answer, ended up getting it right, all the rest of them right. Here I am teaching. He eventually hired me, kind of punchline of the story, right? But my point is, that exact same thing may happen to you on test day, because ultimately what's your goal? Your goal is to get right answers. And you need strategies. You need ways of knowing how to immediately attack a problem if it's in your wheelhouse. But even if you're presented with a question that you may not immediately know how to do, we don't want to just give up. We don't want to just kind of write it off and say, oh, well, I got that one wrong. We want the best possible score. And so it's kind of the mentality to bring to it. And the other thing that I kind of realized was that when it comes to the GRE, there are a handful of topics, a handful of strategies and content areas and question types that produce the biggest results. So you may have this question, especially if you're new to the GRE, where do I focus my time, effort, and attention? And the visual you see on your screen is actually an analogy that I saw once in a live demonstration, and it has always stuck with me. And it's really a metaphor for life, but it's also a relevant metaphor for the GRE. And the illustration is this. Would you believe that the number of rocks and sand in the jar on the right are exactly the same as the number of rocks and sand in the jar on the left? Would you agree with that? Would you believe that? It certainly looks like there's more on the left because they're like overflowing. They're the exact same number of rocks and sand. The difference is with the jar on the right, they put the big rocks in first. You see, if you put all the sand in first and then the small pebbles and then the smaller rocks, there's no room left for the big rocks. But in the jar on the right, they actually put the big rocks in first, and then the smaller rocks can kind of filter in and settle in around it, and the sand can kind of filter in around it. And that's so true with our lives. We spend a lot of time focusing on the small stuff. We prioritize the small stuff, the sand, and we kind of neglect the big stuff, the big rocks, right? So I could go on a whole rabbit trail with that metaphor for life. But when it comes to the GRE, students do the same thing. And they say, okay, I'm going to focus on all these obscure math rules and learning all this really arcane stuff. And they miss the big rocks. They miss the big stuff. And so I'm presenting this to you because I want you to kind of understand where probability and what we're going to be talking about tonight kind of fits in. And also, if you're new to the GRE and you're just kind of thinking, how do I attack this thing? How do I study for this thing? Where should I focus my time, effort, and attention? Here it is on the screen, right? And I don't want this to be discouraging to you. Hopefully it's encouraging to you. You may be familiar with the business principle of the Pareto principle that says that 80% of your results come from 20% of your efforts. 80% of your sales usually come from about 20% of your clients. And on the GRE, it's not quite that. Data analysis is time consuming, Sally, that's right. I wouldn't quite go as far as to say that you only have to focus on 20% of the stuff, but you don't have to focus on all the stuff to get a really high GRE score. And if I were to suggest to you where you should actually spend your time, effort, and attention, I would say number one is learning the non-standard math strategies. If a lot of you guys on this call found out about this because you signed up for one of my free sessions, maybe you've seen me teach some non-standard strategies, those are going to help you get a lot of low-hanging fruit, a lot of right answers. Arithmetic is probably the second most commonly tested thing on the GRE, especially percent change. The GRE loves percent change and ratios, so spend time and attention there. Yeah, the low-hanging fruit, right? You want to get that low-hanging fruit, and this is the low-hanging fruit. If you can learn to master ratios, quadratic equations, and exponents when it comes to algebra, quantitative comparisons has a ton of low-hanging fruit, especially quantitative comparison questions involving variables, because you can learn to make up numbers for those variables and test different types of numbers that guarantee you will be able to figure out the relationship between the two quantities. It takes a little bit of work and skill and practice, but that's some low-hanging fruit once you master those quantitative comparison strategies. Triangles are the most commonly tested geometric figure on the GRE, and so definitely learn triangles, especially right triangles. And then a lot of people forget about the verbal side, right? You want to do well on that. It's a very vocabulary intensive verbal section of the GRE. Oh, and now, by the way, here we are finally at data analysis with probability and combinatorics. Now, that's what we're going to be talking about on the webinar today. But let me say this. I don't want you to feel like you're wasting your time tonight. Quite the contrary. Wait a second, you just said I should prioritize these other things. Well, that's because you're going to see a lot more of those things. The number of questions that you're going to be able to apply my non-standard strategies to are way more than the number of probability questions you're going to see. Does that make sense? Yeah, I had a student call me up recently after taking the official GRE just to kind of debrief, and he said, here's what I saw, and then he said, I was kind of surprised, I really didn't see many probability questions. But that actually makes sense if you think about it, right? Probabilistically, if there's like a whole pie of 100 topics, 100 question types, ratios and word problems and distance problems and sets, and you list them all out in probability and then you only have 40 scored questions between the two quant sections, like how many probability questions are you likely to see? Not all that many. However, here's the good news, right? Okay, so Kenny didn't see many, maybe saw one or two, and that's kind of normal. But here's why this webinar is important and why you're here. Because when you do see them, they can be the difference between a really high score and an average score. And the reason is because they tend to be hard. They tend to be harder questions. If you're seeing them, you're probably doing pretty well. And you want to be able to get them right because now you're getting harder questions right. And so that is going to elevate your score even higher. And so even if you're only going to see 1, 2, 3, maybe 4 at the most probability questions, man, if you can knock them out of the park, boom, now you've separated yourself from your peers. So while I wouldn't spend as much time here as I would on the non-standard strategies, quantitative comparisons, mastering these and everything I'm going to teach you in the rest of our time together tonight is going to be a difference between maybe a 160 and a 163, a 163 and a 165, maybe creeping up into the 90th, 95th percentile because probability questions can be challenging, which is why you guys are here. So let's go ahead and dive in. Actually, let me give you a little teaser. Stick around to the end of the class. First of all, I'm going to teach a lot of good stuff right up to the end, and then I'm going to offer you guys a special promotion at the end, so you'll definitely want to stick around for that. But let's go ahead and dive in. So like I said, strap on your seatbelts. Hopefully you had a chance to download the practice questions that we're going to go over tonight and maybe had a chance to review them so that you're not seeing these for the first time. If you are, that's okay. I'll try to pause the screen a little bit and you can read them and digest them. And again, maybe some of them you thought were hard, some were easy, and that's absolutely true. Some of them are just examples I'm going to use to teach you the basic principles to then solve the harder problems. And this would actually be considered a hard problem. So I'll kind of keep you in suspense on this question. If you have an answer, you can go ahead and type it in. You're curious if you actually tried to do these problems already. So this would be considered a hard probability question, right? And we're going to come back to it, but this is the type of question that can be hard if you don't know what you're doing. But as soon as I teach you 3 foundational building blocks, you now have everything you need to answer any question, any probability question the GRE throws at you, even the hardest ones. So this would be considered a hard problem. But once I teach you the foundational building blocks, we're going to come back to this in about a half hour. And I think you're going to see how much easier all of a sudden it becomes. So without further ado, let me give you those building blocks. And I talked about kind of 3 foundational rules, formulas, and some of the emails I sent out, including the one formula that's going to be most crucial for solving hard problems. But let's just refresh and remind ourselves that probability is simply kind of the measurement of the likelihood of something happening over time or successive intervals, right? What's the chance that it's going to rain? If you bring up a weather report, there's a 40% chance of rain. That means 4 times out of 10, given these weather conditions, it will rain. 4 times out of 10, 40%, that's probability. And probability ranges between 0, meaning 0%, and 1, meaning 100%. So a 40% chance of rain is 0.4, 40%, right? The decimal equivalent of 0.4. So anyway, that's just kind of probability basics and kind of some of the the terminology and notation you will see. And probability questions on the GRE can be solved, even the hardest ones, if you understand three main rules. So hopefully that's encouraging to you. What are those three rules, Brett? That's what I'm gonna show you now, right? Let's start very basic, but we don't want to overlook that. And number one is the basic formula for probability. And it's amazing how often we actually are using this formula without kind of realizing that we're using the formula, right? Like if I said, what's the probability of flipping a coin and getting a heads, right? Heads, tails, one coin, right? Heads or tails. What's the probability of getting a heads? Anyone? 1/2, right? Everybody knows that, 0.5. Not 0.05, Sally. That would be like 5%, but 0.5, 0.5. Yeah, anyway, so 50%, right? 1 out of 2. Well, that's something we just kind of intuitively know, but why is it? Well, subconsciously, we actually applied the probability rule, which says that we want to put the favorable outcomes. What's a favorable outcome? I'm asking about heads, right? So getting a heads is a favorable outcome. On a coin, how many heads are there? 1. So there's 1 heads, 1 favorable outcome. Over how many total outcomes? 2. You either have heads or tails. 1 out of 2, 1/2, right? So like we do it instinctively, but now what if we get a slightly harder question? Now, this is an example of a question that's not overly difficult. If you looked at this question and you said, this is kind of easy, like, is he really just going to be going over easy questions tonight? No, we're not going to just be going over easy questions. And yet this is a question that may appear on the first section when they're just kind of giving you moderate difficulty questions. Yeah, very good, Kenny. So not rocket science, but it's a direct application if you are not careful to keep things straight of the basic rule of probability. So we're looking for the probability of getting a girl who speaks more than one language, right? And that's going to be number of favorable outcomes over total outcomes. And so how many favorable outcomes are there? Well, what is it that we are looking for? What counts as a favorable outcome? Yeah, 8, right? Because it's asking specifically about girls. We want a representative to be a girl, so we're talking about girls who speak more than one language, and that's exactly what is defined right here. Of the total people, 9 are boys and 8 are girls who speak more than one language. So that tells you that there are 8 of them. That becomes the numerator. And the denominator, of course, is the total what? And this is what we have to pay attention to, because this is usually what can change, right? So on a harder question, are they asking for what's the chance of getting a girl who speaks more than one language out of all the people in the class who speak more than one language? That would actually just be 9 plus 8. That would be 17. That's not what they're asking. They're asking that the representative is going to be chosen at random from the class. So it's asking about how these 8 girls compare to not just the subset of girls, of students who speak more than one language, not just that subset. So now I can eliminate answer choice A, C, and E. The denominator is not 17. That would be an eye-catcher wrong answer. It's asking about these 8 girls, numerator. That part's easy. The numerator is easy compared to the entire class. And the entire class is 15 plus 12. And so we have 8 over 27. Answer choice B, Kenny was correct, right? So again, not an overly difficult question, and yet the type of question that you could get wrong if you're not careful. So some of you may have gotten the wrong answer if you tried these questions on your own before this class. Others of you may have kind of stumbled even if you were trying to do it right now, but hopefully you see now just the value of being very clear in your own mind. What counts as a favorable outcome? What counts as a total outcome? And when these get really challenging, sometimes you can only figure out the total by using, combinatorics. You may have to use torics, like permutations or combinations to figure out like how many total outcomes there could even possibly be. And so we'll have to table that for another time, or, I do certainly cover that in my probability and combinatorics lessons. But for something like this, you can figure it out right from the question itself. And Kenny admits, yeah, the biggest problem is sometimes slowing down and realizing, you do have a little bit more time than you realize you have, and just pay attention to the wording. Don't make snap decisions. Use your scratch paper. I would absolutely write stuff like this out on your scratch paper. One of the things my students hear me say all the time is that he or she who uses the most scratch paper wins. So if you're trying to do a bunch of stuff in your head, that's when you're probably making the careless errors. All right, so that is rule number one. And we're going to use that as a building block then for some of the more advanced questions. Again, we don't necessarily have to think too hard about that rule, but just reminding ourselves what it involves and what it entails, to then move up a notch in difficulty. And this now becomes kind of the crux of really what a lot of questions that you're going to see involve. Yeah, we did question number one, Kellyanne. Oh no, we haven't done question number one. We're going to come back to that after I give you the building blocks. So stick with me, and in about 15 minutes or so, 15, 20 minutes, you'll have everything you need to then answer it, including what we just taught, and then this. This is crucial, this understanding of what happens. Okay, so we just learned favorable outcomes, total outcomes, right? Like what's the probability of flipping a coin and getting a heads? 1 out of 2, 50%. But what if I say, what's the probability of getting a heads 2 times in a row, 3 times in a row, 5 times in a row? What's the probability of picking a marble out of a bag and getting a yellow marble twice in a row, picking 2 marbles and both of them are yellow? These types of multiple iterations, repeated iterations, consecutive outcomes takes it up a notch. So what tools do we have in our tool belt to be able to answer those? The first one is questions that implicitly or explicitly say and. Something happens and then something else happens. And when that happens, the rule is you multiply the 2 independent probabilities together. So we still need rule number one to figure out, okay, what was the individual probability? Like what's the probability of getting a heads? 1 out of 2. Like I have to know rule number one for that. But oh, by the way, then if I want to get it again, that independent probability is also 1 out of 2. Let me multiply those together. That's the probability of 2 in a row, right? So see how that works? And you see the formula here. I'm not big on formula memorization. I'm kind of bigger on just intuitively understanding what's going on. But it basically says, hey, if I want A and B to happen, then I just take the probability that A happens and the probability that B happens, and I multiply them together, as you see in this question. All right, so let's go ahead and work on this one. If you already have an answer, you feel free to type it in the chat area, certainly. While I get my pen color correct. So what's going on here? Well, we have a repeated iteration question. How do we know? Because of wording like in a row, right? We don't want to just know the probability of picking a yellow marble. We want the probability of picking 3 yellow marbles, right? So we have this bag, and this is what I always like to do, right? I like to draw pictures to not only illustrate it for you to see, but even on my scratch paper, sometimes when I'm working problems like this, I'll just draw a little bag and I'll say, okay, I got yellow marbles, 5 of them. I got red marbles, 6 of them. I have blue marbles, 9 of them, right? And I'm going to reach into this bag and I'm going to pull them out, and I want to know the probability of getting 3 yellow marbles in a row. So here's my question, and I do this a lot too, right? I have 1 pick, 2 picks, and then the 3rd pick, right? So when I reach into that bag the very first time, what is the probability of getting a yellow marble on that pick? Like if that were the only question and we think back to rule number 1, what's the probability of getting a yellow marble? Yeah, exactly, Fisher. Favorable outcomes. In this case, we're wanting a yellow marble. There are 5 such yellow marbles. Therefore, the numerator is 5 yellow marbles. We have 5 chances out of, what's the denominator? Well, the denominator is total marbles. And of total marbles, of course, is every marble in the bag, which is 5 plus 6 plus 9, 9 plus 6, 15 plus 5 is 20, right? So we have 20 total marbles in the bag. Obviously, then the independent probability of getting 1 yellow marble is 5 out of 2. But now here's where it gets interesting. I'm now going to reach back into the bag and pick again. In that case, on the second pick, how many favorable outcomes do I now have? How many yellow marbles are there still in the bag? And the key wording here, bingo, exactly 4, right? And don't miss this point. This problem was nice to us because it told us that the marble picked is not replaced. It is not put back. In other words, I started with 20 marbles. I get a yellow marble. Therefore, I now only have 19 marbles in the bag for the second pick. So on the second pick, the denominator is now 19. The numerator, of course, is also 1 fewer yellow marbles. There's only 4 yellow marbles left. So the independent probability is of course, 4 over 19, right? And that becomes important. Now, how do you know it's not replaced? A lot of times there's wording like that. If it doesn't specify, assume it is not replaced, right? Because the natural thing would just be to pick it out and leave it out, right? So just assume it's not replaced unless told otherwise, but here they actually told us that it's not. And then now what's the independent probability using rule number 1 for that third pick of a marble? Well, now there's only 3 yellow marbles in the bag, only 18 total marbles in the bag. So those are the 3 independent probabilities. Rule number 2 says we have an and situation. We get a yellow marble and then another yellow marble and then another yellow marble. So we just multiply those together. And you can either get out your calculator since it's the GRE and you have that luxury, or, I just honestly, it sometimes waste time to use your calculator, right? 5/20ths is the same as 1/4, right? 3/18ths is the same as 1/6. Here we have the 4s that cancel, so it's really 1 over 19 times 6. And maybe you get your calculator out to do that, or you just look over the answer choices and say, 19 times 6 is not 100, and it's also a lot bigger than 20, so I'm just going to go with 1 over 114, right? Answer choice A. A small little trick to help you save a few seconds, but for those of you who are looking for time management issues, that's a good way to do it, right? So you don't always have to painstakingly take every single step. But if you did want to use your calculator, you certainly could and multiply that and see that it's 1 over 114. Either way, you get answer choice A. So any questions about that? Like I said, I need to get moving on if I'm going to get through everything, as time's moving along. But any big picture questions about that? Hopefully that made sense, right? So we want to multiply stuff. And I always say, when in doubt, multiply stuff. Like on the GRE, if you're not sure what to do with stuff, when in doubt, multiply stuff. Now, every once in a while, you may add stuff. So this is kind of the second subset to rule number 2. Rule number 2, again, concerning repeated iterations. But sometimes we don't have an and situation. We have an or situation. And or means we're going to add the outcomes. So now we say, okay, we have this independent probability and this independent probability. What's the chance of getting one or the other? Just add them together, right? Just add them together, as you see here, right? So here is a student response question, which we know can happen on the GRE. We don't like those as much because it's harder to cheat. You can't use the answer choices to your advantage. But a question like this is pretty simple and straightforward. Just again, illustrating the point. So this, I hope you found easy if you looked at these questions in advance, but it's designed to be easy to illustrate the concept that we can then use for harder questions. And it simply says, okay, we have a normal, I should specify probably 6-sided die. Sometimes the GRE will give you weird questions, like if you have a 5-sided die, or if you have an 8-sided die and you roll it, blah, 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 right? So that alters the denominator. But here, if we have a standard 6-sided die, we want the probability of a 2 or a 4. And that is simply the probability of getting a 2 or plus the probability of getting a 4. And now we look at the independent probabilities. Rule number 1, what's the chance of getting a 2? Well, there's only one 2 on a 6-sided die out of 6 total sides, so it's 1/6. Yep, very good. That's going to be the eventual answer, Sally. That's right. And then for the probability of getting a 4, again, there's only one 4 out of 6 total sides. So that independent probability is also 1 out of 6. So we just add those together, and 1/6 plus 1/6 is 2/6, which reduces to 1 out of 3, which Sally got correct. How many rolls of the die? Yeah, just in one roll of a normal die. So the question happened to say it. So yeah, just one roll, and the answer is 1 out of 3. You know the way the GRE works, you could have put 2 out of 6 is a correct answer. So of course is 1 out of 3. Anything that reduces to 1 out of 3 would be correct. So this is just a very basic illustration of the concept that OR, so OR means add. Now in this case, the two events are mutually exclusive, a term that you don't need to know on the GRE except conceptually. And what that means is it's impossible for me to roll a 2 and a 4 at the same time. It's impossible. I have to have one or the other. So in that case, I literally just add those independent probabilities up. But what if you have a situation where the two independent events are not mutually exclusive, meaning it is possible for them to happen at the same time? Then we still add those probabilities, but then subtract the overlap, subtract out the possibility of them happening at the same time. So a slight modification to the formula, which is that the probability of A or B is the probability of A plus the probability of B. But now I'm going to subtract out the chance that they're actually going to happen together, as with this example, right? So this example, if you had a chance to look at it already, great. If not, you can read it here, that we are randomly picking one. So Margie, one card. We're picking one card out of a standard playing deck of 52 cards. And by the way, the GRE doesn't actually expect you to know everything about playing cards. You won't see playing card questions on the GRE. They tend not to like gambling. Yeah, so Fisher, you don't have to know this to get a right answer on the GRE. It'll be more like marbles or flipping a coin or things like that, right? So they're no fun on the GRE. But in case you don't know all the rules, that's okay. I'll kind of teach them to you here. Just pay attention to the principle. It says, okay, we're going to reach and pick one card out of the 52 playing cards. So here's the good news. We know the denominator is going to be 52, right? So the first thing is we want to draw either a queen or, keyword or, we're going to add that to getting a heart. So for those of you who do play some cards, how many queens are there in a standard deck of cards? 4. Yeah, 4 queens. Queen of hearts, queen of spades, queen of diamonds, queen of clubs, right? Four of the queens. All right. So if I just said, what's the chance of getting a queen? It's 4 out of 52. But I'm giving you lots of chances. I'm saying you can either get a queen or a heart. That raises our odds significantly. We would expect the probability to go up. So what's now the chance? So we're going to add, right? Plus, what's the chance of getting a heart? Well, again, we're picking out of all 52 cards. The denominator has not been reduced because we're only picking once, so it's not like one of those without replacement situations. That would come into play if I'm asking you to pick 2 cards or 3 cards or playing blackjack, figuring out that probability or something like that. That's not what we're doing, right? So 52, yep. And now, how many favorable outcomes are there? How many hearts are there? There are 13 hearts, right? There's 13 of every suit. 52 divided by 4 is 13. So there's 13 of every suit, 13 hearts. And so some of you may stop there and get a wrong answer, right? So the answer is not 13 plus 4, 17 over 52. So if you type that in over here, you get the answer wrong. Why? Because it is possible there is one card in the whole deck that is the queen of hearts, that is both a queen and a heart. So we want to subtract that out. that overlap. Because what's implicit in a question like this, when you have non-mutually exclusive situations, is the probability that you will draw either a queen or a heart, but not both. Brett, that's confusing. How come they don't just say that? They're trying to trick me. They're not trying to trick you, but now you know. You showed up for this class, now you know. File that away. They're not trying to trick you, but if you see an or question, the implication is but not both. Now, in the case of rolling a die and getting like a 2 or a 4, they can't happen at the same time. But here they can. So we have to subtract out the one overlapping card, the one that is a queen and a heart. And so now it's 4 plus 13, 17 minus 1 is 16 over 52. And you could reduce that or simply type in 16 over 52. And there you go, right? You probably wouldn't see this as a numeric entry question anyway, but that's the way I wrote it up for this, this class, and there you go. All right, so 3, yeah, okay, perfect. And that kind of ... but not both becomes important, all right? So let's kind of recap quickly rule number 2, and that's rule number 3. So rule number 2 is the repeated iterations, and that's the majority of the questions you'll see, the probability questions, you know, picking multiple marbles or flipping a coin multiple times, or something with like picking 3 marbles out of a bag, even if it's the same. Let me say this, even if it's kind of happening at the same time, you mentally want to think about it sequentially. Does that make sense? So let's go back really quickly. What if instead of saying, what is the probability of picking 3 yellow marbles in a row, it had instead said, if you pick 3 marbles out of this bag containing 5 yellow marbles, 6 red marbles, and 9 blue marbles, what is the chance of that all 3 are yellow? That's the exact same question, right? Whether I pick 1 and then another one and then another one, or I literally just pick 3, blindfold and pick 3, it's the exact same probability. So just kind of mentally understand that that's what's going on, right? It's easier to think about it, I picked 1, 2, and 3, but picking 3 at the same time is the exact same thing. Either way, these questions come up a lot. And if we have an and situation, multiply stuff, multiply stuff, multiply stuff. Or situation, we add stuff, and that's pretty much it. And just kind of remember that if we're adding stuff and they are not mutually exclusive, you just subtract out that overlap, right? And that would be a hard question, right? So the premise of this webinar was learn how to solve advanced probability questions. Well, Brett, this doesn't seem very advanced. This seems like a pretty easy question. Yeah, but the concept is advanced. The idea that on a hard question, you have to subtract out that little bit of overlap, that's the difference between a medium difficulty and a challenging probability question, right? So now you know, and just kind of pay attention to that. But now my favorite and most useful and most versatile rule / formula on the entire GRE when it comes to probability. And this is the formula that you would put stars next to and ask, you know, just big exclamation points next to. No, Abraham, you don't have to know that. That's not knowledge that the GRE would expect of you. You're not expected to know anything about playing cards. I just use that as an example to teach you the concept. Yeah, but now you know, Fisher. And Abraham, the GRE will give you benign stuff that's not, the GRE tries not to be biased. So I get this, I actually had a student email me just yesterday asking if, you know, she would be expected to know like the conversion between yards and feet and things like that because she uses the metric system, you know, and stuff like that. The GRE tries not to be biased. It used to be a fairly American-centric exam because this is where it started, but now that more international students are taking the exam as well, it's a very unbiased exam. So you're not going to have to know things that require select knowledge. They'll either tell you some of the rules or they'll use simple things like marbles in a bag. So you don't have to know playing cards. Yeah, number of letters. Yeah, you need to know 26 letters in an alphabet or something like that. Anyway, this rule, probability rule number 3, this is the most useful rule for solving hard probability questions, right? It's useful for very, very easy questions, but it's also the application you want to use for very, very hard questions. And here's what I mean by that. It's useful for very easy questions because just like my example, like the probability of the chance of rain was so second nature to, or sorry, flipping a coin, I think I used flipping a coin. Like 1 out of 2 was so second nature you probably didn't even realize you were using the formula, favorable outcomes over total outcomes. Likewise with this formula, if I tell you that there is a 40% chance of rain tomorrow, what's the chance that it's not going to rain? Go ahead and type 60%, right? Fish. I mean, so it's like, duh, you didn't have to use the formula. We know that probability adds up to 100%. And so if there's a 40% chance of rain, there's a 60% chance of not rain because they have to add up to 100%. And that's all this formula is saying. So we don't even need the formula for something obvious like that. But we may need it for a harder question like this. And this would count as a hard question. Why? Because of the words at least one. So the other rules that we just talked about, repeated iterations, were things like, what's the probability of flipping a coin and getting a heads 3 times in a row? That's just 1/2 times 1/2 times 1/2, right? I get a heads and then multiply, I get another heads. And then multiply, I get another heads. But that's not what this question is asking. This question says, okay, I'm going to toss a coin 4 times, but what's the probability, not just that I get a heads, but that not that I get a heads every time, but that at least one of them is a heads, at least one. And I don't really have a simple, straightforward methodology for that. So what I do want to do is use the other formula that says, okay, let's think about what we don't want and subtract that from 1. So instead of solving directly for what we do want, I'm going to say that the probability of at least 1 heads. I don't really know how to do that. But what I can do is I can figure out what I don't want, what doesn't count, and just subtract that out. So it's 1 minus the probability of not at least 1 heads. Is that part of things a little bit easier to figure out? If it is, hint, hint, it definitely is. That's why this formula is so useful. Now I can solve what otherwise would be a very challenging problem. And in fact, it actually becomes a fairly easy problem, not for most of your colleagues who are going to be taking the GRE, but for you, because now you know how to solve it. Let me quickly say something. I'm going to bring this up. I have a little thing at the bottom, and I'll annotate again. This is kind of an aside really quickly. Probability questions are the question type that is probably easiest to use logic and common sense to eliminate wrong answer choices. So probability can be difficult. And if you see a question pop up on your computer screen that is challenging and you start to freak out and you don't immediately know what to do, generally, you would want to probably skip it anyway, save it, come back to it later, right? Pick the low-hanging fruit that I talked about. I apologize. The ringer will go off in a second. Pick that low-hanging fruit. Save the time to come back if you have a little bit of time and spend the time on, easier questions. So for sure, you definitely want to do that. But even when you come back to it, what you can do is improve your guessing odds, right? So even if you're not sure how to deal with the at least situation, let me ask you this. Do you think it's going to be likely or unlikely that if I give you 4 chances to get even just 1 heads, do you think it's going to be likely or unlikely? Type it in the chat area, right? Likely or unlikely? Likely versus unlikely. Now, that's not very scientific. That's not very exact. Like, what's likely? Well, likely is probably like greater than 50%, like more chances than not it's going to happen. Unlikely, less than 50%. right? So probably not going to happen. So I'm giving you 4 chances, and all you need is 1 heads. That's very likely, because in fact, there's a 50%, 1/2 chance that you're going to get a heads if I only give you 1 flip. That's the probability for 1 flip. I'm giving you 4 chances. So 1/2 is out. 1/2 is the chance I get it on 1 flip, but I'm giving you 4 chances, so it's definitely not 1/2, and it's definitely not something less than 1/2. See how this works? Yes, Sally, exactly. Eliminate A and B. So one of the useful skills for you on the GRE is improve your guessing odds. And you can do this on geometry questions by eyeballing figures. You can do this all over the GRE math section. And frankly, even on the verbal section, there's lots of ways to eliminate clearly wrong answer choices. If you feel stuck because you say, oh, this is hard, you start to freak out, at least I don't know how to, step back, logic and common sense. Let me eliminate some wrong answer choices. Now I've improved my guessing odds. What probability? 33.33% chance. And there you go. But we actually want to solve this. This isn't very difficult now that I've taught you rule number 3. And that says, okay, the probability of getting at least 1 heads, we don't know how to solve directly for that. But I can solve for what I don't want. And what I don't want is not at least 1 heads. Kind of how do I, what does that even mean? Not at least 1 heads. Like, how do I translate in my mind? Not at least 1, that means I get 4 tails in a row. In other words, what I don't want is anything where I don't even get a heads. Not even 1. Not even 1 heads, because that's what it's asking about. It wants to know the probability of getting 1 heads, at least 1 heads. So the opposite of that would be not getting any heads, which is just 4 tails in a row. That's easy. That's rule number 2. Multiply stuff, right? What is the probability of getting tails 4 times in a row? Tails is 1/2, and then another tails 1/2, and then another tails 1/2, and then another tails 1/2. Bingo, 1/16. But that's what we don't want. So we subtract that from 1. So what's 1 minus 1/16? Convert the 1 to 16/16 minus 1/16, equals 15/16. Answer choice E. Well done for those of you who got that in advance, but the easy way to do it is the complement rule of probability. Make sense? All right, now for the fun part. Guys, we're getting close to the end. We got about 10 minutes left. Spend the next 4 or 5 minutes going back to, so you have the building blocks. I've given you everything you need to solve hard questions on the GRE, including question number 1, which really is kind of an aggregate of everything we just learned. All right, so always the word of at least. That's how I would, every time I see at least, Sally, and even at most. So the hard probability questions are going to be the at least questions or at most questions. And they're much more easily solved using the complement rule. 1 minus the probability of the opposite. Think about what you don't want. What is not at least? What is not at most? What's that probability? And then subtract it from 1, and that's almost always easier to figure out. Yeah, that's right. Yeah, I would use the complement rule on any question that asks at least or at most, for sure. All right, and you may use it on a question like this. I think at least 3 heads, Kellyanne, right? Because at least 2 heads? So not at least 2, no, that's different because you might get 1 tails or 0 tails. So you would have to figure out 0 tails, the chance of 0 tails and 1 tails, and add them together, and that's what we don't want, and then subtract that from 1. We could go down a rabbit hole. So you can either send me an email later, Kellyanne, or we could stick around afterwards and talk about it. It's a little bit harder. You could still solve an at least 2 head situation. It's just What we don't want is actually a couple different things. We don't want one tails or zero tails. So anyway, it's just a little bit harder. All right, but let's go back to this question and bring back everything that we have learned and see if we can kind of roll it all into one. So curious if anybody got this on his or her own. If you did, well done. Hopefully you've still learned something from this webinar. But I think I'll make this very easy for you. And the key, guys, use your scratch paper, and write out exactly what you are looking for. All right, so here's the situation. We have a club with 10 members. This becomes important because it's probably going to be the denominator of, you know, some sort of some aspect of the problem is, you know, rule number one, something out of 10 members, right? Including Harry. So Harry's one of the members. All right, and we're going to try to choose, you know, president, secretary, and treasurer, right? So we're going to pick the president, and then of course there's only going to be 9 left at that point. We're going to pick the secretary. So this basically is telling us that we're picking in order: president first, then secretary second, then treasurer third, right? Then would be an and situation, right? President and then secretary, right? And then treasurer. So we're probably going to be multiplying some stuff together. So that kind of sets this scene. And the question is, we're trying to figure out what's the probability that Harry is either, so we have either or, okay, we have a rule for or, secretary or treasurer. All right, what do we do with that? There's an analogy I use in my course that I think is helpful, and it's when you feel stuck, pretend you're driving through the fog with headlights. And what that means is you can't always see the whole road unfold in front of you, but you can always drive just as far as your headlights will let you see. Same thing here, right? You may not see exactly how to do this whole problem because it looks hard and confusing, but you can always do something. Drive just as far as your headlights will allow you to drive. In other words, do something. What can you do? Well, let me break this up a second. Okay, I know what or means. So this is going to be the same thing as the probability of being secretary or plus the probability of being treasurer. And I don't have to subtract the overlap because it's impossible to be the secretary and treasurer at the same time. All right, so was that helpful? Yes. Because what I need to do is I need to find those probabilities kind of separately, and then I'm just going to add them together. All right, so how do we do that? What's the probability of him being secretary? So the probability of him being secretary is what? This is where it gets hard. Is the probability of him becoming secretary just 1/9? No. Why not? Because the president has to be selected first. So what we really want for him to be secretary is the probability that he is not selected president, and then, yes, he's selected secretary. Make sense? And what's that probability? Not quite, Sally. What's that probability? Well, the probability of not president is what? What's the chance that he's not going to be president first? 9/10. There's the complement rule. So first he has to not be picked president. That has a 9/10 probability. And then, now he does have to be picked secretary. Okay, now you're right. Now there's only 9 people left, and there's only one Harry, so now he is picked secretary. That is our probability. 9/10 times 1/10 gives us, the 9s cancel, 1/10. So there's actually a 1/10 chance that he is picked secretary. See how this wraps all of our rules up into one. We have an or situation, we have an and situation, and we have to remember, and this was the important part about getting our mind around what's happening here, that these guys are being selected sequentially in repetition, right? President first, then secretary. So yes, the individual probability he's picked secretary is 1/9, but only if he makes it that far. First, he has to not be chosen president before he is then chosen secretary, all right? But that's only half the battle, because the question says the chance that he's either secretary or treasurer. Okay, so if that doesn't happen, I have another chance, right? I have a chance that he's actually selected treasurer instead. So I have this 1/10 chance plus this other chance. So what's the chance that he's chosen treasurer now? I think we get the idea now. That's the same thing as the probability of not president and then not secretary and then yes, treasurer. Make sense? So he has to first not be president, so that's 9/10 chance of that, and then multiply. What's the chance he is not going to be secretary? Probability rule number 1. At this point, 8/9, right? Because the total number of people has gone down, so the denominator is less. The total outcomes is now only 9 people being chosen from. Only 1 Harry, but the complement rule says we don't want Harry, so there are 8 people not Harry at that point. So the complement rule comes into play. Rule number 3 comes into play to figure out that second iteration. So he is not president, 9/10, and then multiply, not secretary, and then third iteration, yes, treasurer. Now what's the probability he's treasurer? There's the 1/8 we were looking for, right? So the probability of treasurer is not just 1/8. First, he has to not be president, then he has to not be secretary, and then he has to be treasurer. What's all of those probabilities? The 9s cancel, the 8s cancel. Hey, look at that. That's actually 1/10 as well. So the total probability, which we predetermined, we pre-thought, this is the importance of using your scratch paper, we already pre-thought this, is to say, okay, probability of secretary or treasurer is probability of secretary, 1/10, plus probability of treasurer, 1/10, equals 2/10 equals 1/5. Answer choice, E. Take a deep breath. That's a lot of stuff to get there, right? A lot of stuff to get there. You could probably use a little of the logic and common sense and say, do you think it's likely or unlikely? Here, the thing is, it's kind of shades of likeliness. It ranges all the way from like 1/5, 20%, 10%, all the way down to something like really, really small. So maybe you say, yeah, it's kind of likely. I have a pretty good, the individual chances aren't good at all. Like, it's very unlikely you're going to be any of those things. 1 out of 10 chances isn't very good. But if I give you a couple of chances at that, right, because you can either be secretary or treasurer, it's probably something bigger than 1/10. Does that make sense? Just is kind of the logic that I want you to, yeah, Kenny, this would be a hard question to get in under 1:45. This would be a really hard, really challenging question. But now that you know the step-by-step methodology, that's the point, is you should be able to do it a little bit faster now. But here's the other thing too, right? The logic says, hey, the worst odds you have are being president, and that's 1 out of 10. But I'm giving you 2 chances. I say you could be secretary or treasurer, so I've kind of doubled your odds. So let me get rid of A and B, right? And probably C. So maybe here too, I have a 50-50, guess at worst, right? So don't forget to use every tool in your toolbox to improve your guessing odds, right? Cool. Sally says cool. Kenny says this is going to be hard. That's the only mathematical solution, Sally. And there's really no way to work backwards. Like, there's not a non-standard strategy for this. You can't work backwards from the answer choices. I think the best shortcut would be to kind of say what I said, which is kind of like, okay, if I have like roughly a 1/10 chance of being, really kind of what I have is like a 1/9 chance of being a secretary, and kind of like a 1 plus an or situation, kind of a 1/8 chance. Like, it's not exactly 1/9 plus 1/8, but it's kind of close to that. It ends up being roughly, it's 1/10 plus 1/10. The point is it's better odds than that. So that kind of puts me closer to 1/5 than it does to 1/9. So that can get me close, like if I have to cheat. But yeah, this is the only actual mathematical solution. All right, guys. We are up against it. I promised you to stick around to the end. I hope you have found this valuable, certainly. At the very least, you have the building blocks. You might need to go back and wrestle with this. Like I said, I've condensed several hours of my probability content into like 1 hour. We haven't even touched the combinatorics, but you now have some building blocks to do some really hard, really challenging probability questions. And if you master these 3 kind of basic building blocks that I talked about, you really have everything you need to know to answer any probability question they will throw at you. So what now? Dive deeper. I've alluded to my full course. I'd love for you to partner up and not only get the probability stuff, but get the combinatoric stuff, get the algebra stuff, get the arithmetic stuff, get all the non-standard strategies that I've talked about, everything. So what I'm doing is I'm going to offer you a discount on the full course. Yeah, I'm going to offer a discount for the full course that's going to be really absolutely everything. It's a proven system, helping people boost their scores, taking the guesswork out of preparing for the GRE. You're going to get a step-by-step syllabus that will literally walk you step-by-step through everything you need to know, which videos to watch, which homework problems to do, when and what practice tests to take. Every step of the way, I'm there coaching you, working with you, helping you. You're going to get all the content, all the strategies, the non-standard strategies that I alluded to that I think are kind of like the big rocks that you really should prioritize. Kind of let's work on the big rocks first, the non-standard strategies, the arithmetic, the algebra, the triangles. It's all in the course. But most importantly, it's going to give you that confidence. Jared was one of my former students. He sent me this email after he kind of took the course and then took the GRE. And I love what he says that I highlighted. He said, yeah, okay, I learned skills, I learned strategies. He said, but kind of the main thing I got was a newfound a sense of test-taking confidence. It's saying, you know what? And hopefully you have even more confidence even just after this hour together that, hey, there's like a method to the madness. There's some stuff I can learn. Wow, this was the starting point. You've given me hope. I get that a lot. Like, I have hope again that I can actually beat this test. Yes, it's a beatable test if you have somebody helping you and showing you the ropes. And that's exactly kind of what Jared was saying here. So very simply, offering 15% off my full GRE prep course. It's already incredibly affordable compared to others in the industry. Sometimes I offer a 10% discount, so I'm going above and beyond that here just for you on this webinar for showing up, spending an hour of your time, special 15% discount. And you simply use this coupon code at checkout to save 15%. Enter GRE Save 15 at checkout. This is only good through the end of the week, though. So I know some of you have to think about it. Maybe you have to wait till you get your paycheck on Friday. I know, I'm not going to put you on the spot and, hey, you have to order in the next hour. You're like, I'm not arming anybody. But at the end of the day, if you're sitting here thinking, you know what, I think I do need a little extra help. I think Brett can help me get there. Would love to work with you and would love you to save 15%. I'll give you till Friday to use this code. So it expires on Friday. And let me just kind of break down what that's going to look like for you. If you've never looked at my website or kind of seen my pricing, I think you're going to see it's pretty affordable as well. My silver package is kind of the base package on the full course. It's normally less than $300, $297. And with the 15% discount, now you're looking at $252, so roughly about $250. So you're saving about $50 with this discount, incredibly affordable. And so basically what's going on is the foundational teaching, all the videos, all of my instruction, all the strategies, content, it's all the same in all 3 packages. The major difference is that when you kind of bump up from the silver package, with the gold package, I actually include the course textbook. I will send you a copy of the official guide to the GRE, currently the 3rd edition. And I think it's a valuable book to have, not for the instruction. I don't teach from the book. In fact, there's not very much instruction in the book, but because it's a great source of practice problems straight from the makers of the GRE. And I think it's invaluable to work sample questions straight from the actual people who write the questions that you're going to see on test day. And so I assign a lot of my homework problems from that book. I'll send you the book. If you don't already have it, go with the gold package. And I also include 3 additional full-length practice tests with the gold package. So silver package is great, probably the most popular course because a lot of students already have the textbook and maybe they're wanting to save money for whatever reason. A lot of people go with the silver package. But if you don't have the book and you want some extra practice tests, still can't beat $337, especially with this discount savings. Go with the gold package. I'll send you the book. And the platinum package, I'm going to send you the textbook, I'm going to send you a bunch of extra practice tests. And what's cool about my platinum package is I host a live office hours session every Wednesday night. That's me sitting here in an environment like this with you every Wednesday night. And I just answer any questions that you or other students might have who sign up for the Platinum package. It really is an office hours. I don't just show up and teach, but it's a great way for you to almost get kind of like tutoring built in, for me to work with you kind of in that small group environment. And if you have a question from your homework or practice test or whatever, we go over those together on Wednesday nights as well. That's the Platinum package, ordinarily $497 and only $422 with a 15% savings. So with that, it does expire on Friday. Hopefully you'll choose to take advantage of it. And in the meantime, you can reach out to me anytime via phone. You see the number here, via email. I'm very responsive and look forward to working with you. So hopefully you found this valuable. I will stick around for a minute or two to answer some questions, but I'm going to go ahead and stop the recording now and empower you to go out and dominate the GRE. Take care, everyone.